Alright, let's go over some basic lab equipment. Has anyone ever seen a beaker before? So beakers are used for holding various chemicals. They're not very precise in measuring. They can give you a rough estimate. If the requirements are about 200 milliliters or something like that, if you needed exactly 200 milliliters, you wouldn't use a beaker to do it, because usually you get between like 10 or 20 milliliters off. It's hard to get very precise in beakers. So if you need like an excess of water or just a rough estimate, you would use a beaker. Graduated cylinder is used to precisely measure the volume of liquids or run experiments. So if you need to be way more precise, you would use a graduated cylinder. Do each of you know how to read a cylinder?
To the side, you don't look at the middle. Look on the side.
Do you know what the meniscus is? The meniscus. Very important that you know how to read a graduated cylinder. Alright, there are two meniscus, or menisci, depending on the liquid. So if I have a line right here that says 100 milliliters, so if I have exactly 100 milliliters of a liquid, because of surface tension, I'm going to exaggerate it, the water level is going to do something like this. Let me make it actually touch. It's going to be rounded at the top. You always measure off of the bump. So when you look in, you'll see it touching the side of the glass, but you do not measure from where it's touching the glass, you measure from the top. You could also have the situation where, again, it's at 100 milliliters, and the liquid has gone above 100 milliliters. So the liquid, again, is above the line, but you always measure between the center of the parabola shape. Again, here, so you'll have an air gap right here. You measure from right here. That's called the meniscus. So, our Erlenmeyer flask is used to approximately measure the volume of various liquids. You would want to use a Erlenmeyer flask if you want to mix some chemicals together. Because of the shape, whenever you swirl it, the liquid won't splash out. If you use the beaker and you sit here and shake it, the liquid's going to stick because of surface tension, climb up, and you will spill it. So if you need to like put salt and water and make salt water, you'd probably grab an Erlenmeyer flask so that you can swirl it and get it to mix. Again, it's not very precise in measuring. A Florence flask is often used to boil liquids. Also used to collect gases if applicable. Volumetric flask is used to prepare very precise solutions, volumes. They're only good for one specific volume. But usually, so the difference between a graduated cylinder and a volumetric flask is one volumetric flask can only do one specific volume, but it can also do a much larger volume. Graduated cylinder usually can't hold that much. A reagent bottle is used to store, transport, or view reagents such as acid or bases. If you were to ever go through one of these, be careful. As you don't know what you're picking up. So oftentimes they'll have acid in it or bases, and you don't want to grab by the lid of it and have it drop down, dropping acid on your foot. Also, handling the tops of them, sometimes the acid will leak out and corrode the surface. Usually you keep these separated, the more dangerous ones away, but you'll often see like an entire rack or box full of these little bottles containing different chemicals. A rubber stopper is used to close flasks and test tubes. The holes allow the insertion of glass tubing, probes, or thermometers as needed by the experiment. Test tubes and rack used to hold chemicals tubes while experimenting, not for measuring precisely. And remember to waft if you need to smell anything going on, as the tight container allows for concentrated gases to occur. So in a test tube, whenever the gases build up, if the gas is heavier than the air, it will sit and just get more concentrated inside the test tube. Eventually, there will be no oxygen inside the test tube. There will be nothing but that pure chemical. To some degree, there will be some trace amounts of air. Which means if you want to take your nose and get close to it, you could breathe in a highly concentrated mixture of that gas. Always aim away from your face. A distillation flask. We won't be doing any distillation, at least this year. We don't have any of the equipment to do it. But it's used to separate liquids based on boiling point. I don't know, I might try to order some. That is a good experiment to be doing. I didn't see any in the lab. A barrette and barrette clamp, used to precisely measure or dispense liquids. A barrette is like a very thin graduated cylinder with a little eyedropper end at the very end of it. A ring stand and a ring clamp. Base pole for setting up for experimenting. Holds glassware in place for heating or evaporating. Test tube brush is used for cleaning. You must clean test tubes before and after you use them. The worst thing that could happen is if you get a dirty test tube and you pour something in it and it immediately starts reacting, and you aren't practicing safe distance as soon as you pour it in, or safe direction, and it immediately spews out boiling hot liquid as the chemicals won't react, heat up, and start boiling. Test tube holder, used to hold it. If you heat it up, do not touch it with your hand. Use tongs or a test tube holder. Thermometer, used for measuring temperature. Always use metric. Do not ever use Fahrenheit in this class. All temperatures must be done in metric or Kelvin. Otherwise, the math does not work. Hot plate, used to heat up substances. Bunsen burner, used to heat up substances very quickly and to high temperatures. Do not have any alcohol or flammable materials nearby. Rubber tubing, used for a variety of things, connecting Bunsen burner to gas valve stem, connecting glass tubing together. Wire mesh or gauze, is used to absorb and spread the heat of the flame. Keeps glassware from cracking and breaking. Part of the ring stand. So if you're going to be heating up anything up, you don't want the flame to be concentrated on a single point. You want the flame to spread around the surface of it so that you're not getting one part of the glass super hot. The mesh and the mesh causes the fire or flame to spread outward and basically heat up the mesh. Clay triangle holder used to hold crucible in place on a ring stand. Also helps absorb and spread the heat of the flame as part of the ring stand setup. Crucible and cover used for heating substances and can withstand high direct heat. You can heat these up to very high temperatures. I've seen a lot of crucibles where you can pour liquid iron into them, and just basically you can heat up and melt steel and iron in them, and they don't themselves melt or burn. Crucible tongs is used to carry the crucible. Beaker tongs used to carry beakers once they've been heated. Some of the chemicals in the lab are old but still usable. Because Texas is very humid, moisture gets in, and you might require a mortar and pestle to grind them up. Scupula, used to scoop up chemical powders. Not a measuring instrument. Coolers don't have handles, they're just it's a little V shape. Has a little V that goes in and scrapes. Usually good for test tubes if you need to get something out of them. Stirring rods used to stir, clean in between uses, or they do hold on to the chemical. A striker, if anyone ever used a striker, you basically, it's like a bobby pin. So you press it together, it causes the very end to produce a spark. If you do it over a flammable gas, the gas will catch on fire. It has a finite number of uses, so don't just sit there and click it, or you will waste it. A watch glass used to show chemical reactions. It causes the chemicals to spread out, and also transparent from underneath. Evaporating dish used to evaporate excess liquids. A centrifuge used to separate suspensions or solids from liquids. Meter stick used to precisely measure length. 1 meter is equal to 10 decameters. 1 meter is also equal to 100 centimeters, which is also equal to 1,000 millimeters. We will be using the metric in this class. Funnel, if you need to safely transfer substances from one container to another. Dropper and bottle, used to measure out small amounts of liquid for experiments. Wash bottle usually contains deionized water. Does anyone know what deionized water is? Is another name for pure water. It is very hard to make and get a hold of pure water, because pure water always contains ions or salts in them. Even your tap water contains like lime and other contaminants in it. You almost never find pure water in nature. It always has some radicals, either salt or some other sodium bicarbonate or something in them. This is deionized water. What happens if you drink something without electrolytes? Did y'all ever study osmosis in biology? So what if you drink deionized water? and your cells have salts in them. So if you drink pure water, the salts from the cells are going to go through the cell wall and try to make the pure water try to equalize through osmosis. Your cells will shrivel up. Do not drink pure water. Shouldn't be drinking anything in the lab to begin with. Handy for rinsing glassware and for dispensing small amounts of deionized H2O for chemical reactions. For chemical reactions, you often need pure water, though, as the contaminants in it can mess up the reaction. Goggles and aprons used to protect your eyes from clothing and clothing from damage. These must be worn in the lab. If we're not using any chemicals, glass, or fire, I usually don't make you wear them. Inoculating our flame loop. Used to collect samples from colony bacteria. We won't be doing it in this class. Also, you can put chemicals on the very end of it, in the hoop, and then put it over a fire and watch the fire change colors as the chemical burns. Digital balance, used to accurately measure mass, only up to 200 grams in our lab. Triple beam balance, do y'all know how to work a triple beam balance?
Yeah.
That's what we have the most of. It's the most precise thing we have in the lab. Measures the mass of an object, makes certain the balance is correctly calibrated before use. We have some digital pan balances you need to very accurately compare to masses. Centigram balance, used to precisely measure the mass of a substance. It's more precise than a triple beam balance. Pipette, pump, and bulb, used to precisely measure the volume of liquids in small amounts. We will probably be just using Burrell pipettes, which are disposable, that are graduated so you can measure small amounts of chemicals. Capillary tubes are used to collect liquids through the process of capillary action. Have y'all all seen those, or at least most of them, before? I don't think anything was too out there, unless anything that was, we don't have. Have any of y'all ever read a material safety data sheet?
We went over them in ISO last year. We didn't actually do anything on it.
So if you have any concerns about a chemical, look up this material safety and data sheet. It tells you every single thing you need to know. Looking at the next page. This is an example one. I cover acetone. So it'll tell you the chemical product, company identification in section 1. Section 2 will tell you its composition, information on ingredients. So acetone is a pure chemical. It's also known as dimethyl ketone or 2-propanone. Section 3 is more important. It tells you the hazards involved. So acetone, also known as fingernail polish remover, is a colorless liquid with a sweet odor. It is a flammable liquid and a serious fire hazard. It's extremely flammable. Its vapors are very easy. If there's a spark next by, it will catch on fire. Irritating to body tissue. Avoid all body tissue contact, and is slightly toxic to ingest. Vapors may cause weakness, fatigue, nausea, headache, and skin contact can cause dermatitis. If you don't know, dermatitis is a form of a rash. So basically, do not spill it on your skin. If you spill it on your skin, you need to quickly wash it off. First, and then it goes section 4, what to do if case of accident. So if we look at external, wash continuously with fresh water and mild soap for 15 minutes if you get it on you. If you get it in your eye, immediately flush with fresh water for 15 minutes to save your eyesight. Internal, give no more than 1 to 2 cups. Do not induce involvement in it, and we have to call poison control. Don't drink it. So, you can see here, you can go and read. It basically tells you everything you need to know. So, firefighting, accidental release, handling and storage. You don't need to worry about handling and storage because you won't be storing it here. That's something I would have to look at whenever I buy chemicals. Exposure, what stuff you need to be wearing. Properties of it, chemical formulas on section 9. It also tells you some very important chemistry stuff. Toxicology information. And so forth. It's very good to, even if you think something is very common and you played with before, like I'm sure some of y'all at least have played with acetone. Who hasn't played with acetone? And when I say played, I meant used. Who hasn't used it? I mean, it's common enough that almost every single person has used it. It's very, it's used like in cleaner to do the whiteboard. But if you read it, you should know that if you do get on your skin, it will damage your skin and cause dermatitis. It is actually toxic, and you do not actually want to do it or get any on you. When cleaning your fingernails or using it as fingernails, you want to avoid putting it on your actual skin, as it can mess up the area around your skin. So material safety data sheets are to be provided by suppliers with all deliveries, must be accessible to everyone in the workplace, must be current, must be made available to attending physician in the event of exposure. So I will have material safety data sheets for any chemicals we use in the lab. And if you want to read one, you can, or request it. So flammable. So looking at some words you should pick out from the material safety data sheet. Flammable, any substance easily ignited and quick burning, including liquids with a flash point below 95 degrees Fahrenheit. So what flammable means is if you get any spark or lighter or up in flame, it will catch fire. Toxic, any substance alone or via chemical reaction able to cause harm, produce injury to the body through either absorption, ingestion, inhalation, or ingestion. So acetone is considered toxic. And caustic. Caustic means that it's able to burn, damage, or destroy organ tissue by chemical reaction. So that'd be like acid or a base. So flash point is the lowest temperature at which a liquid produces enough vapor to ignite. Density is percentage of water and air, specific gravity. Permissible exposure limit. So in chemistry and labs, even though there's dangerous chemicals in there, you're allowed to be exposed to dangerous chemicals to some degree. Like accidentally getting acetone on your skin, Wash it off afterwards. As long as you don't keep it on your skin, it won't do that much damage. It takes time to do it. So there's a permissible exposure limit is the standardized, recognized by the industry as the maximum amount or concentration of a chemical that a worker may be exposed to. Basically, it's how much it can get on you, or you can be around for a length of time. Threshold limit value is a recommended limit for chemical substance exposure similar to PEL, but most often more restricted than PEL. And then time-weighted average, an 8-hour time-weighted average is the concentration the average worker can be exposed to during an 8-hour workday, day after day, without harmful effects. One of my friends, he travels the country. He's been to all 50 states. He goes every single state, constantly, almost every week he's in a new state. And what his job is install X-ray machines at dentists. He has to wear a badge because he receives a lot of radiation. Radiation, we're all constantly receiving radiation. TV, your cell phone, it's alright to be allowed some radiation. The sun is a very significant source of radiation. It causes skin cancer. However, we don't always, just don't constantly break out in skin cancer when we walk outside. There's a prolonged exposure that increases the odds of you actually receiving cancer or harm. His is so many amounts of radiation per, I think, 2 weeks or a month. As long as he doesn't exceed over that, it's considered safe for him to be around, and he just has a badge that monitors the radiation he's received over the last month. Some things are done with 8 hours or a single 24-hour period, which again, in this school, you'll only be exposed to it at most for 45 or 50 minutes, which would be this STEL, short-term exposure limit. How much you could probably keep on your skin for about 15-minute period with no ill effect. Ceiling is the maximum concentration never to be exceeded. This is the important one. I know it's ultra blurry. I don't know why this PowerPoint has a really blurry image inside of it. But you need to be able to look at this hazard diamond and be able to understand what it means about a chemical. It's the first thing you'll notice whenever looking at a chemical bottle, is it would have on it a large hazard diamond. The very left is health hazard. 0 is going to be normal material. It poses no health hazard to you. This is like how poisonous it is. So slightly hazardous, extreme danger, and deadly. So cyanide is a 4. Do not ingest or get cyanide on your skin. Water would be a 0. Fire hazard, how easily it ignites and burns. Gasoline is, I believe, a 4. Burns very easily. I know acetone is definitely, looking at its material safety sheet, should be a 4 on there. But it talks about the points in which you can catch on fire. The yellow or right side is going to be the instability. It's how much it reacts. The right one not only talks about instability, but also does corrosion, how much it corrodes. So like acids, if you see the right number is high, it means it could eat through metal, it could eat through your skin. It could also, if it's referring to like explosive material, how much it may detonate. So like, And then the bottom one has specific symbols. Acid, what is just the word acid. A base or alkali is ALK. Corrosive is COR. Oxidizer is OXY. Oxidizers are highly explosive. Did anyone hear about the Beirut explosion? Ammonium nitrate is an oxidizer. It's what they were storing, very common. P for polymerization, radioactive. But here's a good one to memorize. It's a W with a line through it. Do not mix with water. That usually means that if you take a single drop of water and put on it, it explodes. Or it reacts violently, causing it to boil. There's a lot of chemicals what are highly reactive with water. So looking back at the material safety sheet, the identity, its ingredients and structure, substance. Looks up classification, hazards and identification, dangers for humans and the environment. Another thing, there are some chemicals what is highly illegal to go outside and just throw them on the ground. It's major fine. It's they have environmental laws because it can either poison the water supply or kill local wildlife or completely destroy all the grass around the area. First aid, what should you do in case of eye contact, skin contact, ingestion. Firefighting. So some fire extinguishers cannot be used on chemicals because it reacts with it. Some are ineffective. So you would need to. So if we're dealing with something that that is highly flammable, you might want to look and see make sure the fire extinguisher we have does it. Most of the time, I'm going to be looking at this. This is for your benefit too. You want to look and know. Accidental release measures and spill/cleanup. I always like looking at this spill and cleanup. For example, acetone. If you drop it, it quickly vaporizes and fills the entire room with acetone. One, if there's any sparks or anything, and blow up. Another thing is you're unable to breathe in the room with it. So in case of a spill or cleanup, does anyone know how does it say in acetone? See, we have a data sheet. So, number 6, restrict unprotected personnel from the area. Remove all ignition sources and ventilate area. Contain spill with sand and absorb it. Deposit sealed bag or container. Basically, go in, put sand and stuff in the room, evacuate, and let it all evaporate on its own. You don't pick it up because you can't breathe in the room. Handling and storage, exposure and controls. This tells you information about how proper protective gear and equipment. Physical and chemical properties. When doing chemistry on some things, you'll need to know like formula weight, boiling point, occasionally, and formula weight and density are the number 2 used along with the chemical formula. Stability and reactivity. So you need to, it'll tell you which chemicals you do not want to get near. So for example, acetone, do not put it near A strong oxidizing agent, as you can build a bomb. Toxicology. So for acetone, it tells you that it's severe eye irritant, causes dermatitis. It also tells you that it targets liver and kidneys. So ingesting it or leaving it on your skin for too long could be destroying your liver and kidneys. There's no data for the ecological information because it just evaporates so quickly. Transport information, we don't really need to know about transporting it. Any questions? That's it for today. These are just notes.